So this video is about mental maths, the continuation from the previous video. And we're going to start with compensation. Okay, so compensation means you've got pairs of numbers that I'm either going to add, subtract, multiply, or divide. You can do compensation with any of the four basic arithmetic operations. You just have to keep them all straight. So let's start with addition. Okay, and so for addition, you're going to move some number from one addend to the other. So let's say I have 98 and 47. Okay. And basically what we're going to do is, and I'm going to show this way. I'm going to, what do I want? Well, if this was 100, it would be easy to do. So I'm going to move 2 that direction. Okay, so I've got, that'll give you 100. And if I move 2 things over there, I get 45. And this is 145. All right. And this is also the way to show this. So first of all, I think that's fairly clear by itself, but it doesn't quite matter. So if it helps you especially to think about what you're doing and moving 2 that way, then we've got that. Okay. Let's do a little bit maybe more difficult one. $410 plus 985. So there's a couple of ways you can do this. I'm actually going to walk through both of them and just see maybe which one is easier. One, you might think, so what you'd like to do is, so just like up here, we were close to 100, so we want to try to make that 100. So that's close to 400. So maybe what we'll do is we'll move 10 that direction, right? To do 400, 995, and then for, you got 1395, right? Okay. Or another way to do this would be, I could move 15 over, right? So I make that 1,000, right? And so if I'm taking 15 away from this is a little bit tricky, but just sort of count down by 5s, and I end up with 395 and 1,000, and I get 1395. Again, the same answer. All right. I think either is fine. I probably would go this way. I think it's a little bit easier, just because this, taking away 15 from that, right, it goes down into the 300s, so that may be a little tricky. Okay, so that's addition. So all you're doing is moving values around. Now let's look at some subtraction compensations. Not to each, to minuend and subtrahend. Subtrahend. Okay. All we're going to do, I think, again, an example is a better illustration of all of this. It's just we do the same thing to both. So let me start easy. Say 47 minus 13. So this is the thing you've got to remember with this is, again, the minuend and subtrahend, is what you really want to do is make the subtrahend, the smaller one, usually a multiple of 10 or 100 or something easy to subtract, right? And so the easy thing to do would be to make that to 10, I'm going to just subtract 3 from this. Right, so that would be 44 minus 10. And if you want to, you can just do a little arrow up here which says minus 3. And that maybe will help you, what you just did. And I get 34. So, okay, let's do 169 minus 52. Okay. This one actually isn't too bad in terms of, you know, if I write this down, I can kind of, if you can put the column algorithm in your head and do that subtraction, it's really not too bad. There's no regrouping type of thing. Let me show you how to do this with compensation though. I'm going to try to make that a 50. So again, I'm going to take off minus 2, 67 minus 50, and then that's hopefully pretty straightforward. 117. Okay. All right, and finally, well, not finally, I have a 423 minus 97. Okay. So in this case, I'm probably going to go, oh, well, that's almost 100. So let's actually add 3 to both. So 426 minus 100 is 326. All right. And then before I leave this, let me just point this out. What happens to this? This is another common thing. I might look at that and go, oh, well, this is almost 50, right? So if I have this one, right, and let's say I do the add 3 to get 50 minus 16, okay? This is correct in terms of using compensation. The question is this thing any easier to do than that, or is it easier to do than that? And the answer is this is much easier to do, right? Because you're just subtracting 10, right? There's no sort of regrouping, borrowing type of thing. You would have to do that in this case. So this is correct, but harder. Okay. So by correct, I mean mathematically correct. Okay, just harder. Again, with all these mental math things, what we're trying to do is make the problem easier. And I don't think that does this. All right, let's look at, I'm going to just write compensation up here because that's what we're doing. Next one will be multiplication. All right. So multiplication, what are we doing? So multiplication works like addition in here. So what we're going to do is shift a factor. This is going to be a little confusing of each factor. And that's kind of the way to have to word it. But let's go through and talk about some examples here. So let me say I've got 50 times 14. Okay. And what we're going to want to do is I'd like to, again, to make one of these a really easy number to multiply by. Right. And if that was 100, this would be pretty straightforward. So how am I going to do that? Well, I'm going to move a 2 that way. Okay, so not in an addition way, and I'm not going to write times 2 or anything else like this, because that's a times already. So what I'm doing is I'm going to shift like this, and I'm going to get 100 times 14, which is 1400, right? So And what we've sort of done, let me just sort of say this is maybe a little bit of a shortcut of looking at it this way. And this is a perfectly fine way to write it as well. 50 times 2 times 7, which is 50 times 2 times 7, which is 100 times 7, which is what happened. I screwed this up, sorry. 700. Glad I caught myself. Okay. So basically this kind of shows all the gory details of like sort of why everything's working, right? And when I did this, and after I fixed it, sorry about that, what I'm going to do is I'm going to take 2 out of the 14 in terms of, that's a factor of 14, I'm not adding, and I'm not getting 12 there, right? 2 times 7 is 14. Moving that over to get that. Okay. All right, let's look at another one. I have 250 times 6. Okay. So, this one might be a bit of a puzzle thing here. So one thing you might think about is, oh, well, if I multiply that by 4, then I can get 1,000. The trouble is 4 is not a factor of 6. So that won't quite work. So let's look at maybe the other way around. There's actually a couple ways we can do this. Maybe I'll do both of them. So one thing I'm thinking of is maybe I take 5 out of this and move it that way, right? So I'm going to go 5 like that. So I'm going to get 50 times 30. Right? 50 times 30 is 1,500. Right? Or one other way to do it would be if I move 2 there, I get 500 times 3, which is also 1,500. So that looks fine. And it doesn't, to me, I don't think there's any difference here. Plus, I mean, one of the things is in your head, it doesn't matter. I mean, typically what I would do is I would think about this and go, all right, let's see if there's something that I can do kind of quickly. And if just depending on what comes to mind, you just follow that route. So when you're doing mental math, you're often not like you're trying to come up with the answer. You're not necessarily trying to come up with oh, here's 6 different ways of doing it, and this might be the best, right? That's just kind of crazy, right? But just follow some path as long as you're sort of thinking about things the right way. Okay, and then the last is going to be division. Division works a lot like subtraction, and I can multiply or divide both divisor and dividend by same factor. Okay. So 305 divided by 5, for example. Okay. With this, dividing by 5, not too bad, but a nicer thing to do would be divide by 10. So I'm going to do times 2 there. If I multiply that by 2, hopefully that's not too hard to get 610. Right? It's 600 and 2 times 5 divided by 10. So I multiply that by 2, multiply that by 2, I get that. The result is 61. And this is 1,300. Let's make this a little more clear. Okay. Let's look at this. 25, not the nicest to multiply by. If I did, again, if I had 100, it would be great. So 1300 times 4. So this is where your multiplication facts are pretty helpful. I like to have everything under 15 as like in your times tables pocket. So that's 13 times 4 is 52. 100 div 100 is 52. So. Okay, so that wraps up this. This is all about mental math and